Okay, lesson 24.1, graphing polynomial functions. So one of the things you want to pay attention to here, some notation stuff. When we talk about end behavior, we're talking about what happens at the end of the graph itself. So as x approaches positive infinity, so in other words, if you're looking at a graph, let's say a quadratic for instance, what you're talking about is, sorry about that, is when x goes to the right, what is the function doing? Well, in this case, it's going up. So it's going up to positive infinity. When x is going to negative infinity or to the left, that's all that means. You trace the function going to the left, then this is going up towards positive infinity. So the notation they're going to use here is f of x. So what is happening as you go to the right on the function? And then you denote f of x is going to positive or negative infinity, depending on what the function itself is. So we're going to look at some examples here of some different functions. So here we go. So again, as x is going towards positive infinity to the right, so we get on the function, as we go to the right, it's going up to where? Positive infinity. Now you can put the plus here, you don't have to, but you can put it if you want to. What about as x goes to the left? So trace the function going to the left, this function's going up again to positive infinity. Okay. What about the next one? Here's a different polynomial function. We put it in a graph. Okay, as x goes to positive infinity. So again, as you go to the right, where's this going? It's going up to positive infinity. And then as x goes to the left, right here, it's again going up to positive infinity. Okay. Now, let's talk about the direction changes. How many times does it change direction? For this one, it changes direction one time. And the reason that is because it goes, as you go from left to right, it goes down and then it goes up. So it has one direction change. What about this next one? You go down, then up, then down, then up. So that one has what? What has 3 direction changes. Now, one way you can think about this is how many humps does it have? This one has 1 hump. This one has 1, 2, 3 humps. So the number of humps, you can say, is the number of direction changes. So let's look at the next example. Okay. So we look at it. Direction changes, we have 1, 2, 3 humps again. So this one has 3 direction changes. Now, let's do our end behavior as x goes to positive infinity to the right. So as we go to the right on this graph, just go over here on the far right, where's it going? It's going down to negative infinity. Then as x goes to the left, negative infinity, so we go on the left side, where's it going? It's going down to negative infinity again. Now, why did that happen? Well, we think about this. It is multiplied by negative. What's a negative do? It reflects it. So just like the previous one was an x to the 4th function, you notice that it went up on both ends, but when we multiply this now by a negative right here, it goes down on both ends. Why? Because it reflects it. Another thing to note, a lot of times, not always, but a lot of times the power of the function, this is a 4th degree function, x to the 4th power, means it has 3 direction changes because it has 3 humps. Now, it's not always true because, again, if we come over and look at this one, that's 4th degree, but it only had 1 hump. The reason is it doesn't have all this other stuff added to it. So you can't always abide by that rule, but it does work a lot of times. Okay, so even and odd. So let's talk about even and odd. Couple of things to note here. Whenever something is odd, so a linear function, degree 1, you notice on the negative side, it should go down. On the positive side, it should go up. Here's another odd one, degree 3, called a cubic function. On the negative side, it's going down. On the positive side, it's going up. Degree 5, a quintic function. On the negative side, going down. On the positive side, going up. Whereas a even function this case degree 2, quadratic, goes up on both sides. Degree 4, called a quartic function, goes up. So even functions should increase. Why is that? Because if you think logically, anytime you raise a negative number to an even power, it always becomes positive. Whereas an odd function, if you have a negative number raised to an odd power, it still stays negative, which is why the odd functions here in the negative side all go down. So here are some ways that they apply that. And the coefficient, remember what we just got through saying in the previous slide, is that if the coefficient is positive, it maintains its behavior. But when you multiply it by negative, it reflects it. Okay, so this goes back to the whole transformations. Multiply by positive, an even function goes up. Multiply by negative, an even function goes down. Okay. All right, let's look at some near-term problems here real quick. For each graph, identify whether the polynomial is even or odd. Well, in this first one, it's an odd. And the reason I know it's an odd is because on one side, it's doing one thing. On the other side, it's doing something totally different. Okay? Whether the leading coefficient is positive or negative. Well, typically, odds, if they're in the negative quadrant, should be negative. But in this case, it's a positive. Therefore, it's been multiplied by a negative. So that leading, I'm going to abbreviate, coefficient, LC, is a negative number. Okay? Now, if you need to, you can go back and look at the previous slide and see what it basically looks like. Okay? Next one, we look, and this is an even function. Why? Because it has the same behavior on both sides. It's doing the same thing. Therefore, that must be an even function. In this case, whenever you raise a negative to an even power, it makes it positive. So in this case, it maintains that behavior. It's still positive here. Therefore, my LC here is a positive number. If it were a negative, then it would reflect it, which means everything, it would be making it negative behavior. So classifying as even and odd, there are ways to tell this. One is exactly what we said earlier. If it's an even function, when you put a negative in, you still get a positive value. Whereas in an odd function, if you put a negative in, you get a negative value. So that's how you look at it in the functional form. But again, we're just trying to think, basic behavior determining whether it's even or odd. So here are a couple more year-term problems. Classify each graphed polynomial as odd or even. Okay, so again, we look at behavior on the two ends. Two different behaviors. Here it's going up, here it's going down. Since they're not behaving the same way, that makes this one an odd function. Identify whether the leading coefficient is positive or negative. Okay, so again, in this case, when we put in a negative, if it's odd, we should get a negative, but we're getting a positive. Therefore, that means I've multiplied this one by a negative number. Okay, let's look at the next one. This side, they're behaving the same way. They're both going down, so it has the same behavior. So in this case, if it's the same behavior, that means it's an even function. Now, what should happen? When it's an even, when you put in a negative, you should get a positive. When you put in a positive, you should get a positive. But I'm getting negative values down here. Why is that? Because my leading coefficient is also a negative number. So in this case, both of them are negative. So we're really just kind of looking at functions. This particular homework, you're going to be doing page, look down here, page 1162, numbers 1 through 18. So again, all you're doing is looking at it. You're talking about the behavior, looking at is it odd or even, and what's the leading coefficient value going to be.